Welcome back to Snooze to Astronomy. Tonight we will be taking you through a long journey of transcendence and relaxation through 201 facts about the moon. So lay back, close your eyes, and enjoy the video. The moon was born from fire and chaos. Scientists believe that around 4.5 billion years ago, a Mars-sized body named Theia collided with the early Earth. The impact was so violent it ripped away chunks of Earth's crust and mantle, scattering molten rock into orbit. Over time, these fragments merged into the glowing sphere that would become the moon, a child of destruction and creation orbiting its wounded parent. The moon is locked in a gravitational embrace with Earth, always showing us the same face. This synchronous rotation means a single lunar day equals a single lunar orbit. For billions of years, Earth's gravity slowed the moon's spin until it became tidally locked. As a result, the far side of the moon remained hidden from human eyes until the 20th century, inspiring endless myths about what lay beyond. The surface of the moon is scarred with craters, each one a memory of cosmic bombardments. Without an atmosphere to protect it, meteoroids and asteroids slam into its surface at tens of thousands of kilometers per hour. Some craters are so ancient they date back nearly 4 billion years, preserving the violent history of the early solar system better than any record on Earth. Lunar Maria, the vast dark plains that blotched the moon's face, are not seas but ancient lava flows. Billions of years ago, impacts fractured the lunar crust, and molten rock seeped out, flooding basins and cooling into basalt. These Maria give the moon its distinctive man-in-the-moon visage, a face carved by fire and shadow that has watched humanity since the dawn of time. The moon has no atmosphere to speak of, only a fragile exosphere made of helium, neon, hydrogen, and traces of other gases. This tenuous veil cannot shield it from radiation, meteors, or the harsh vacuum of space. Every footprint and rover track from Apollo still remains, undisturbed by wind or rain, eternal testimonies to the moments when humans first walked another world. Despite its silence, the moon holds water, not in flowing rivers or seas, but as ice locked within shadowed craters near the poles. These craters never see sunlight, reaching temperatures colder than Pluto, preserving ice for billions of years. Future explorers may one day mine these frozen reserves, using them for drinking water, breathable oxygen, and even rocket fuel. The moon stabilizes Earth's tilt, acting like a cosmic anchor. Without it, our planet would wobble unpredictably, causing chaotic climate shifts that might have made advanced life far less likely. The moon's presence has been a silent guardian, keeping Earth's seasons steady for billions of years, shaping the very conditions that nurtured humanity. Every night, the moon pulls on Earth's oceans, creating tides. The gravitational tug elongates our planet slightly, lifting water into bulges that follow the moon's orbit. This constant rhythm has guided sailors, shaped ecosystems, and influenced cultures for millennia. Tides may have even played a role in the evolution of life, helping early creatures adapt between land and sea. The moon is slowly leaving us. Each year it drifts about 3.8 centimeters farther away as tidal interactions transfer energy from Earth to its orbit. Long ago, the moon loomed much larger in the sky, but in the distant future it will appear smaller, and total solar eclipses, those perfect alignments of sun and moon, will no longer be possible. From Earth, we see only half of the moon, but the far side is not dark. It receives just as much sunlight as the near side, but its face is different, covered in rugged highlands and far fewer Maria. When the Soviet spacecraft Luna 3 sent back the first images in 1959, humanity was stunned. The hidden hemisphere was alien and ancient, like gazing into the moon's forgotten soul. The moon is riddled with caves and tunnels created by ancient lava flows. These lava tubes could stretch for miles beneath the surface, shielded from radiation and temperature extremes. Future lunar colonies might be built inside these natural shelters, turning the moon's volcanic scars into havens for humanity's next step outward. Though lifeless, the moon vibrates. During Apollo missions, seismometers left on the surface recorded moonquakes. Some were caused by tidal stresses, others by meteor impacts, and a few by thermal expansion when the surface heated after long, freezing nights. Unlike Earth, the moon rings for hours after a quake, as if it were a bell struck by an invisible hammer. Cultures around the world have tied myths and legends to the moon. In ancient China, the story of change tells of a woman who drank an elixir of immortality and floated to the moon. where she still lives with her rabbit companion. In Greece, Selene was the goddess of the moon, driving her silver chariot across the sky each night. The moon is not just a rocket, it is a mirror of human imagination. The moon's phases guided ancient calendars. Farmers timed planting and harvests to lunar cycles, while festivals and rituals often aligned with the full moon. Even today, the Islamic and Hebrew calendars are lunar-based, and countless cultural traditions trace their rhythm to the waxing and waning glow that has kept time for humanity across ages. The first humans to set foot on the moon were Neil Armstrong and Buzz Aldrin in July 1969. Armstrong stepped onto the lunar soil. His words echoed across Earth, declaring a giant leap for mankind. That moment marked the first time in history that humans walked on another celestial body, forever binding our destiny with the wider universe. The moon is littered with artifacts from exploration, flags planted by Apollo astronauts, lunar rovers, discarded landers, scientific instruments, even golf balls hit by Alan Shepard remain there. They form a time capsule of humanity's first steps beyond Earth, waiting for future travelers to rediscover. The moon's surface is covered with regolith, a fine, powdery dust created by eons of impacts. This dust is sharp and clings to everything, sticking to astronaut suits and equipment. Some Apollo astronauts even reported a distinct gunpowder-like smell from lunar dust brought into their landers, though its true composition differs from anything on Earth. In many cultures, the moon was seen as a timekeeper of fertility. Ancient peoples noticed how its cycle mirrored the human menstrual cycle, leading to associations with fertility goddesses and the rhythms of life. Even now, phrases like moon cycle carry echoes of those ancient connections between the heavens and human biology. The moon is smaller than Earth by far, but it is the fifth largest moon in the solar system and unusually large compared to its planet. This makes Earth and the moon more like a double planet system than a simple planet-moon pair. Their relationship is unique, a cosmic partnership unlike any other in our solar neighborhood. Solar eclipses occur because of a perfect coincidence. Though the sun is 400 times larger than the moon, it is also 400 times farther away, making them appear almost exactly the same size in the sky. This alignment allows the moon to cover the sun completely, plunging Earth into darkness during total eclipse. Snooze, a breathtaking event unique to our planet and era. The moon glows with reflected sunlight, but its surface is far darker than it looks. The albedo of lunar soil is only about 12%, similar to worn asphalt. Its brightness is an illusion, a trick of contrast against the night sky. In truth, the moon is a gray, shadowed world, luminous only in borrowed light. Lunar craters come in all sizes, from tiny pits to the immense South Pole Lightcon Basin, one of the largest known impact craters in the solar system. This basin stretches 2,500 kilometers across and plunges over 8 kilometers deep. Studying it may reveal secrets about the moon's interior and the violent history of impacts in the early solar system. Though it seems barren, the moon may hold treasures of immense value. Helium-3, a rare isotope carried by solar wind, has accumulated in lunar soil over billions of years. Some scientists dream of mining it for use in future nuclear fusion reactors, turning the moon into a potential power station for humanity. The moon's gravity is only 1/6 that of Earth. Astronauts could leap high into the air and carry heavy loads with ease. But the low gravity also makes movement awkward, as Apollo astronauts discovered falling slowly and often tumbling in their bulky suits. Living long-term in such conditions will require humans to adapt in body and mind. The moon has inspired art for millennia. Poets have written odes to its glow, painters have captured its silver light, and musicians have composed symphonies beneath its gaze. From Shakespeare's sonnets to Van Gogh's starry skies, the moon has been a muse unlike any other, reflecting not only sunlight but the deepest creativity of humanity. Unlike Earth, the moon lacks a global magnetic field. As a result, it is exposed to constant solar and cosmic radiation. Only small local magnetic anomalies remain, remnants of a time when the moon may have had an active core. These ghostly fields hint that the moon's heart once pulsed with molten fire before cooling into silence. The moon's distance from Earth is so precise that ancient astronomers could use it to predict eclipses with remarkable accuracy. The Babylonians, thousands of years ago, tracked lunar cycles and learned to forecast celestial events. This early astronomy laid the foundation for modern science. with the moon as the first great teacher of the skies. Even now, the moon shapes human behavior. Studies suggest slight correlations between lunar phases and sleep cycles, mood changes, and cultural rituals. Whether real or symbolic, the moon continues to exert a pull not only on oceans but on the tides of human thought and feeling. As it has since the dawn of our species, the moon's brightness shifts not only with its phases but also with its position in the sky. When it rises near the horizon, it appears larger and more golden due to Earth's atmosphere scattering light, an illusion called the moon illusion. This has enchanted poets and mystified philosophers for centuries, making the rising moon one of humanity's most captivating spectacles. During a lunar eclipse, the moon does not vanish into darkness but instead glows with a deep copper-red hue. Earth's atmosphere bends sunlight around the planet, filtering out blue light and allowing red hues to wash across the lunar surface. Ancient cultures often feared these blood moons, interpreting them as omens of war, famine, or great change. While modern observers marvel at their otherworldly beauty, the moon has been humanity's first stepping stone into space. But it may also become our future outpost. Plans for lunar bases envision using local regolith to build habitats, shielding astronauts from radiation and micrometeors. Ice in polar craters could sustain life and fuel rockets, making the moon not just a destination but a gateway to Mars and beyond. The moon is tied deeply to mythology across continents. The Inca believed the moon goddess, Mama Quilla, watched over women, marriage, and calendars. In Norse myth, the god Mani drove the moon across the sky, chased by wolves. Each culture saw stories written in the lunar glow, finding gods, spirits, and guidance in its nightly dance. Lunar phases have shaped human superstition. Farmers planted by the waxing moon, believing growing light encouraged strong crops. Hunters tracked animals more easily during full moons, while some feared madness, lunacy under its bright glow. Though science explains the moon's phases, its influence over human imagination is far harder to dispel. The moon's surface experiences extreme temperatures. Without an atmosphere, daytime on the lunar equator can reach 127 degrees Celsius, while nighttime plummets to 173 grados bajo cero. These brutal shifts make survival a challenge, requiring any future explorers to rely on technology or subterranean shelters where temperatures remain more stable. Ancient astronomers were able to measure the moon's distance with surprising accuracy. The Greek philosopher Hipparchus used lunar eclipses to calculate it more than 2,000 years ago, estimating it at about 30 Earth diameters away. Modern measurements confirm it is around 30.1 Earth diameters, distant proof that the moon has long been our most measurable and knowable companion. The moon is covered with impact glass, tiny shards formed when meteorites strike its surface and melt the regolith instantly. These glass beads tell scientists about the conditions of ancient impacts and even preserve traces of solar wind particles, offering a frozen record of cosmic history sealed within glittering grains. Moonlight is only reflected sunlight, but its silvery glow changes how we perceive the world. Colors fade, shadows lengthen, and landscapes transform into eerie monochrome. Poets called it enchanted, lovers called it romantic, and soldiers once called it dangerous, as bright nights made stealth nearly impossible. The moon reshapes not just the sky, but the very ground beneath us. The moon inspired some of the earliest science fiction. In the 2nd century AD, Lucian of Samosata wrote True History, a tale of travelers carried to the moon by a whirlwind. Centuries later, Jules Verne and H.G. Wells envisioned lunar voyages in works that inspired real scientists. The moon was the first dream destination for humanity's imagination. Long before rockets made it possible, though Earth has only one moon, other planets boast dozens. Jupiter and Saturn hold swarms of moons, some larger than ours. Yet Earth's moon is uniquely influential. Its size compared to our planet makes it far more important for tides, stability, and cultural impact than the moons of giants ever could be. The moon's orbit is not perfectly circular but elliptical. At its closest perigee, it appears slightly larger in the sky. At its farthest apogee, it seems smaller. When a full moon coincides with we call it a supermoon, an event that dazzles skywatchers with an especially bright and looming lunar face. Some Apollo astronauts described the Earth as rising above the moon's horizon, a view called Earthrise. Photographs of this breathtaking sight showed our planet as a fragile blue marble in the void. These images became iconic symbols of unity and environmental awareness, changing how humanity saw itself in the universe. The moon's gravity, though weak compared to Earth's, still has profound effects. Apollo astronauts had to learn to walk differently, adopting a loping, bounding gait to keep balance. In low gravity, every step became exaggerated, turning the simple act of walking into an alien dance on a silent stage. Micrometeorites constantly rained down on the moon, peppering its surface with new craters and melting soil into tiny glass. These impacts are invisible from Earth, but relentless. The lunar surface is a battlefield of constant bombardment, its skin forever reshaped by the universe's ceaseless artillery. The moon has been used as a mirror for science. Astronauts placed retroreflectors on its surface during Apollo missions, allowing scientists to fire lasers from Earth and measure the moon's distance with centimeter precision. These experiments confirm that the moon is drifting away, one slow heartbeat at a time, an eternal experiment that still continues today. Lunar orbits are complex. The moon wobbles slightly as it moves, a motion called libration. This wobble allows us to glimpse about 59% of its surface from Earth over time, though never the full far side. It's as if the moon is teasing us, tilting just enough to reveal glimpses of its hidden secrets before turning away again. In Japanese folklore, the moon is said to house a rabbit pounding rice cakes, a figure visible in the shadows of the lunar Maria. This contrasts with the Western man in the moon image, but reflects the same human instinct to find faces, animals, and stories written into the moon's mottled features. The moon has no liquid water, but it bears scars from ancient volcanic activity. Some features, called sinuous rilles, are winding channels carved by lava rivers billions of years ago. These frozen rivers of stone snake across the surface, reminders that the moon was once a molten, restless world. In many Native American traditions, moons were named to mark the seasons: the wolf moon of January, the harvest moon of autumn, the snow moon of February. These names connected the sky's rhythms to life on Earth, guiding agriculture, hunting, and cultural ceremonies tied to the glow of the lunar cycle. The moon has inspired countless religious rituals. Hindus celebrate festivals like Karva Chauth and Sharad Purnima under its light, while Buddhists observe Vesak during a full moon. Ancient Druids also marked solstices and equinoxes with lunar alignments. Across faiths, the moon has been a calendar of sacred time, connecting human souls to the cosmos. Unlike stars, the moon does not twinkle. Its light travels directly from the sun and reflects steadily to our eyes, untouched by the atmosphere in the way starlight flickers. This steady glow makes it a reliable guide in the night sky, a lantern unblinking amid the shimmering constellations. The moon influences Earth's rotation. As it pulls on our oceans, friction slows the planet's spin, lengthening days over millions of years. Long ago, Earth's days were only 18 hours long. In the far future, they will be longer still, the moon silently stretching our measure of time. The moon is slowly becoming a hub of exploration once again. Nations like the United States, China, and India are sending new missions, mapping resources, and planning landings. The dream of lunar bases is reviving, and the moon may soon shift from a symbol of achievement to a foundation for humanity's expansion across space. Legends say the moon affects human health, particularly sleep and dreams. Some studies suggest sleep patterns shift slightly around full moons, with people sleeping less deeply. Whether biological or psychological, the belief that moonlight stirs restlessness remains alive. Blending folklore with subtle science, the moon was humanity's first laboratory. Beyond Earth, Apollo astronauts conducted experiments from seismic sensors to solar wind collectors, laying the groundwork for planetary science. Each mission carried not only explorers but entire suites of instruments, turning the barren surface into an extension of Earth's scientific reach. Moon rocks brought back to Earth are priceless scientific treasures. They revealed the moon's volcanic history, its bombardment scars, and its ancient link to Earth. These samples are older than most rocks on our planet, untouched by weathering or plate tectonics. A library of the early solar system preserved in stone. In ancient Mesopotamia, the moon god Sin, or Nana, was revered as a deity of wisdom and cycles of time. Temples were built to honor the waxing and waning light, tying human understanding of timekeeping to the phases of the moon. These early beliefs helped shape humanity's first calendars and systems of order. Even now, when astronauts look up at the moon from Earth, they know that it is a silent partner in our cosmic story. The moon has been with us through every step of civilization, a silent witness to the rise and fall of empires, the discovery of fire, and the birth of science. Its glow is not just reflected sunlight, it is reflected history. The moon is tidally locked to Earth, meaning one side always faces us while the other remains hidden. This synchronous rotation was once seen as mysterious, but it's the natural result of gravitational interactions over billions of years. The so-called dark side of the moon isn't actually dark, it receives sunlight, but it's forever out of our direct sight, giving it an air of secrecy and allure. The far side of the moon is very different from the near side. While we see vast dark Maria lava plains, the far side is heavily cratered with fewer smooth plains. This asymmetry is likely due to differences in crust thickness. The near side's thinner crust allowed lava flows to spread after impacts, while the far side remained more rugged and ancient. The moon may look lifeless, but it still quakes. Lunar seismic instruments placed by Apollo astronauts detected moonquakes, some triggered by meteorite impacts, others by tidal stresses from Earth's gravity. Some quakes were surprisingly strong, lasting for more than 10 minutes. These tremors reveal the moon's interior is not entirely dead, but still slowly settling. Unlike Earth, the moon has no protective atmosphere. This means it cannot shield itself from meteoroid impacts, solar radiation, or cosmic rays. As a result, the lunar surface is scarred, ancient, and vulnerable. A lack of atmosphere also means there's no weather, no wind, no rain, no erosion, allowing footprints from Apollo astronauts to remain preserved for millions of years. The moon has regions of eternal darkness. At the poles, some craters are so deep that sunlight never reaches their floors. These permanently shadowed regions remain at temperatures colder than Pluto and are thought to harbor ancient, pristine water ice. They are among the most valuable and mysterious places on the moon for future explorers. The moon was likely formed in a colossal cosmic collision. The leading theory, known as the giant impact hypothesis, suggests that 4.5 billion years ago, a Mars-sized body called Theia struck Earth. The debris from this cataclysm merged in orbit, creating the moon. This shared origin explains why lunar rocks are so similar in composition to Earth's crust. The moon's surface is covered by regolith, a blanket of fine, powdery dust mixed with sharp rock fragments. This dust is dangerous for explorers. It clings to everything, wears down equipment, and can damage lungs if inhaled. Yet regolith is also a potential resource, containing oxygen, metals, and material that could be used for construction in future lunar colonies. Though the moon looks peaceful from Earth, its surface is violent. With no atmosphere to burn up meteors, even tiny space rocks strike the moon at high speeds, creating craters instantly. New craters are still forming today, though they are usually small. In this way, the moon's face is continuously rewritten, one cosmic impact at a time. The moon influences life on Earth in subtle ways beyond tides. Studies suggest that certain species, like corals, synchronize their spawning with lunar cycles. Birds and sea turtles use moonlight for navigation, while predators and prey adjust behaviors to the brightness of the night. In this sense, the moon silently shapes ecosystems across our planet. The moon's surface is brighter than most realize. Though it looks gentle in the night sky, its regolith reflects about 12% of incoming sunlight. Standing on the surface under a full sun, the brightness would be dazzling. During Apollo missions, astronauts wore visors to protect their eyes, as the lunar day is far harsher than it appears from Earth. The moon's gravity, though weak, is still powerful enough to raise tides on Earth. These tides influence coastal ecosystems, marine life, and even the rhythm of human activity. Without the moon's pull, Earth's tides would be far weaker, dramatically altering the evolution of life in oceans and the shape of coastlines we know today. The moon appears perfectly round, but it is slightly squashed. Its shape is more like an egg, with the larger end pointing toward Earth. This bulging shape is a result of gravitational forces during its early molten history. To the naked eye, the difference is invisible, but precise measurements reveal this subtle distortion. The moon's surface is littered with rays, bright streaks radiating from young craters. These rays are made of ejected material from impacts, stretching across hundreds of kilometers. Over time, space weathering darkens them, but fresh impacts create new streaks, painting the moon's face with ever-changing patterns. The moon has a faint atmosphere called an Unlike Earth's thick, breathable air, the lunar exosphere is so thin that its atoms almost never collide. It is composed of trace amounts of helium, neon, and hydrogen, along with sodium and potassium that sometimes give the moon a subtle glow. It's more like a ghostly veil than a true atmosphere. The moon is slowly drifting away from Earth at about 3.8 centimeters per year. Over millions of years, this will lengthen Earth's days and change the tides. In the far future, the Earth-Moon relationship will look very different. Our nights dimmer, our oceans calmer, and our days longer. The moon is slipping away from us, slowly but inevitably. The moon once had an active magnetic field billions of years ago. Evidence in lunar rocks shows that its molten core generated a field strong enough to shield the surface. But as the interior cooled, the magnetic field died, leaving the moon vulnerable to cosmic radiation. Today, only faint traces of magnetism remain in scattered surface rocks. The moon reflects the story of early Earth. Because it lacks weather and plate technology, its surface preserves a record of the solar system's violent youth. By studying lunar rocks and craters, scientists can piece together Earth's own history, which has been erased by erosion, volcanism, and shifting continents. The moon's phases shaped humanity's first calendars. Before writing, ancient people tracked time by observing the waxing and waning crescent. Many early months, the word itself comes from munth, were based on lunar cycles, tying human life to the rhythms of the sky. Even today, some cultures still follow lunar calendars. In medieval times, people believed the moon affected health and emotions. Doctors timed bloodletting and surgeries to lunar phases, while others warned that madness peaked during full moons. Though science dismisses most of these claims, the idea that the moon pulls not only on tides but on minds persists in folklore and language. Hence, the term lunatic. The moon has been mapped in extraordinary detail. Modern missions like NASA's Lunar Reconnaissance Orbiter have photographed every crater and ridge, creating maps with resolutions of just a few feet. These maps are so detailed that we can see the tracks left by Apollo astronauts decades ago, preserved exactly as they were made. The moon has inspired art for millennia. From ancient carvings to Van Gogh's swirling starry night, its silver glow has been painted, sung, and written into human culture. Its light represents mystery, romance, solitude, and longing, shaping the stories we tell about ourselves and the universe. The moon's color changes with the atmosphere. When low on the horizon, it appears orange or red, as Earth's atmosphere scatters shorter wavelengths of light. Higher in the sky, it appears white or pale silver. These shifts have inspired countless metaphors: the harvest moon, the blood moon, the silver moon, all born from light meeting air. The moon holds clues about water in space. Tiny glass beads in lunar soil contain hydrogen and oxygen from solar wind, suggesting water molecules can form even in harsh space conditions. Combined with ice in polar craters, this evidence suggests the moon is not entirely dry and may play a role in sustaining life in future missions. The moon has been struck by spacecraft intentionally. Missions like LCROSS crashed probes into shadowed craters to analyze ejected material, confirming the presence of water ice. While destructive, these impacts provided groundbreaking science, turning crashes into discoveries about the moon's hidden chemistry. The moon's craters vary in size from microscopic pits to massive basins. The largest, the South Polaitkin Basin, is nearly 2,500 kilometers across and 13 kilometers deep, one of the biggest impact structures in the solar system. Studying it helps scientists understand how giant impacts shaped planets and moons across the cosmos. The moon occasionally causes daytime surprises. Solar eclipses occur when the moon passes directly between Earth and the Sun, perfectly covering the Sun's face. This alignment is only possible because the moon and Sun appear nearly the same size from Earth's perspective, a cosmic coincidence that creates one of nature's most awe-inspiring events. The moon plays a role in climate stability. By stabilizing Earth's tilt, it prevents wild swings in seasons. Without the moon, Earth might tilt chaotically, leading to extreme ice ages or scorching periods. Our planet's relative climate stability owes much to the silent pull of the moon. The moon is slowly becoming a new frontier of competition. As nations and private companies eye its resources, questions arise about ownership. mining rights, and preservation. Just as oceans and continents once defined human expansion, the moon may become the next stage for both cooperation and conflict in space. For all its familiarity, the moon still holds mysteries. We don't fully understand why its near and far sides are so different, or how deep its interior structures go. Each mission reveals new surprises, strange magnetic anomalies, unexpected ice, or unusual rock chemistry. The moon is both a neighbor and an enigma, close yet still full of secrets. The moon's surface is a record of the solar system's history. Every crater marks an ancient impact, a cosmic memory frozen in time. Unlike Earth, where wind and rain erase scars, the moon holds on to its wounds forever. It is a natural archive, a library written not in ink but in stone and dust. The moon's Moriah, those dark, smooth plains visible from Earth were once seas of lava. Billions of years ago, volcanic eruptions filled giant basins with molten rock. As the lava cooled, it created the darker patches we see today. These seas are not filled with water, but with the memory of fiery cataclysms. The moon's highlands, in contrast, are ancient and bright. They are made of anorthosite, a light-colored rock that reflects sunlight more strongly than the Maria. These highlands are older than most Maria, dating back to the moon's earliest crust. Looking at the moon is like seeing two different worlds stitched together. Dark, volcanic scars against a bright, ancient crust. The moon's surface is covered in tiny glass beads formed by impacts and volcanism. These beads glitter under microscopes, remnants of violent processes that once shaped the moon's face. Some are colored, ranging from orange to green, revealing chemical differences in the lava from which they came. Apollo astronauts even discovered orange soil in one region. During Apollo 11, when Neil Armstrong stepped onto the moon, he described the soil as very fine-grained and almost like a powder. Yet despite its softness, the dust was abrasive and clingy. It stuck to suits, scratched visors, and gave astronauts headaches. The moon may look serene, but its surface is hostile to human visitors. The moon's low gravity, only 1/6 of Earth's, makes movement strange and joyful. Apollo astronauts bounded, hopped, and stumbled across the surface, discovering that skipping was easier than walking. Each leap was slow motion, each step exaggerated, as though the moon itself invited playfulness. Even in the midst of historic exploration, the moon has its own time zones of light and dark. A single lunar day lasts about 29.5 Earth days, meaning 2 weeks of daylight are followed by 2 weeks of darkness. This slow rhythm creates extreme temperatures, blazing heat in the day and freezing cold at night. Surviving on the moon requires adapting to its long alien cycle. The moon's temperature swings are extreme. At noon, the surface can reach 127 degrees Celsius, 260 degrees Fahrenheit, hot enough to boil water. At night, it plunges to -173 degrees Celsius, -280 degrees Fahrenheit, colder than Antarctica's harshest winters. Without an atmosphere to moderate conditions, the moon is a land of brutal extremes, where heat and cold wage endless war. The moon's horizon looks different than Earth's, because it is smaller. Its curvature is more obvious. Standing on the surface, astronauts could see the horizon much closer, giving the impression of a world that ends quickly. This proximity made the moon feel intimate, like walking on a small stage lit by the sun. EARTHRISE is one of the most iconic views ever captured. When Apollo 8 orbited the moon, astronauts saw Earth rising above the lunar horizon, a fragile blue marble floating in blackness. That photograph transformed humanity's perspective, reminding us that our planet is small, delicate, and alone in the vast cosmos. The moon has been humanity's mirror for myths. Ancient cultures saw faces, animals, and gods in its patterns. The man in the moon, the rabbit, and countless legends emerged from the shapes of craters and Maria. The moon became a canvas for imagination, a celestial storyteller that whispered differently to every civilization. The moon guided sailors for centuries. Before GPS, navigators used lunar positions and eclipses to measure time and longitude. Its steady rhythm made it a dependable companion on voyages across oceans. Even today, the moon remains woven into the art of navigation, a guiding light in the dark. The moon affects Earth's rotation. As it pulls on Earth's oceans, it also transfers angular momentum, slowly slowing Earth's spin. Our days are lengthening by tiny fractions of a second every century. Without the moon, our planet's spin would be faster, our nights shorter, and our balance of time forever changed. The moon was humanity's first stepping stone beyond Earth. The Apollo missions were not just technological triumphs but symbolic acts of leaving home. For the first time, humans stood on another world, seeing Earth as a distant globe. The moon taught us that space was not unreachable, but a frontier waiting for courage. The moon has a thin layer of dust that glows faintly at times. Some Apollo astronauts reported seeing a strange twilight glow before sunrise and sunset on the moon. Scientists believe this may be caused by electrostatically charged dust levitating above the surface, a mysterious and haunting phenomenon unique to the lunar environment. The moon has been a muse for poets. Shakespeare spoke of its changeable face, Shelley of its silence, Li Bai of its companionship during solitude. Across languages and centuries, the moon has been a partner in human emotion, a silent witness to joy, grief, longing, and wonder. The moon's craters reveal the scale of cosmic violence. Some impacts struck with energy surpassing billions of nuclear bombs. Yet these craters are not just scars, they are laboratories, exposing deep layers of the moon's crust and offering clues to planetary formation. Each crater is both destruction and revelation. The moon has valleys carved by ancient lava. Sinuous rilles, winding channels etched across the surface, mark the paths of long-cooled rivers of molten rock. These strange, snake-like formations are unlike anything on Earth and remind us that the moon was once alive with fiery motion. The moon may contain valuable helium-3, a rare isotope carried by solar wind and trapped in regolith. Helium-3 could one day fuel nuclear fusion reactors, offering near-limitless clean energy. This possibility has turned the moon into a potential treasure chest for future civilizations. The moon's polar regions are uniquely important. Permanently shadowed craters may hold billions of tons of water ice, vital for drinking, oxygen, and rocket fuel. Sunlit ridges nearby receive constant light, ideal for solar power. Together, these regions could become the first footholds of human settlements beyond Earth. The moon reflects humanity's resilience. From ancient myths to the space race, it has been both unreachable and yet always present. Every culture has looked up and wondered. Every generation has carried the moon in its imagination, and when humanity finally touched it, it was a reminder that our dreams can indeed leap across the stars. The moon's surface holds remnants of human presence, from American flags to seismometers, from a plaque left by Apollo 11 to the bootprints of 12 astronauts. Artifacts of exploration remain undisturbed. They are monuments not of conquest but of curiosity, preserved in silence beneath an eternal sky. The moon will one day bear new footprints. Modern missions from many nations are preparing to return, bringing astronauts back after decades. Unlike Apollo, these missions aim to stay longer, build habitats, and use lunar resources. The moon is no longer just a destination, it is the gateway to the wider solar system. The moon inspires unity and competition alike. The Apollo missions were born of the Cold War, a race between superpowers. Yet when humans looked back at Earth from its surface, they saw no borders, no nations, only one world. The moon is both a stage for rivalry and a mirror reminding us of our shared home. The moon may harbor volcanic glass, useful for construction. Tiny beads formed by explosive eruptions could be melted into bricks or glass panels for habitats. Lunar resources could allow settlers to build directly on the surface, reducing the need to transport materials from Earth. The moon's regolith contains oxygen bound in minerals. With the right technology, this oxygen could be extracted to provide air for breathing or fuel for rockets. Far from barren, the moon could support life through careful use of its hidden chemistry. The moon connects generations. The same face we see today was seen by ancient farmers, pharaohs, emperors, poets, and explorers. Its permanence ties us to all who came before, a common sight across human history. The moon is a thread weaving together our story across time. The moon is slowly cooling. Like Earth, it once had a molten interior, but over billions of years, it has lost much of its heat. The cooling caused the surface to shrink and crack, creating scarp steep cliffs that mark the moon's gradual contraction. The moon is literally wrinkling with age. The moon's size relative to Earth is unusual. Most planetary moons are tiny compared to their hosts, but our moon is nearly a quarter of Earth's size. This makes the Earth-Moon system unique in the solar system, almost like a double planet. This closeness is why the moon exerts such profound influence on Earth. The moon is central to cultural calendars. Festivals like Ramadan, Passover, and Lunar New Year are tied to its phases. Even in modern life dominated by solar calendars, the moon still governs sacred rhythms, celebrations, and traditions across the globe. The moon has inspired exploration in literature, from Jules Verne's From the Earth to the Moon to modern science fiction. It has always been imagined as humanity's first step outward. These stories shaped dreams that eventually became real rockets, real missions, and real footprints. The moon's surface glows during a lunar eclipse. When Earth blocks sunlight, some light bends through the atmosphere and paints the moon red. Every eclipse is a reminder of the alignment between Earth, moon, and sun, a cosmic dance that has inspired awe for thousands of years. The moon carries Earth's memory. Fragments of ancient Earth may have been blasted to the moon by impacts, preserved in lunar soil. Studying these rocks could reveal secrets about our own planet's earliest days, secrets long erased by Earth's shifting and erosion. The moon is humanity's rehearsal for Mars. Missions to the lunar surface will test technologies for habitats, resource use, and survival. What we learn there will shape how we reach further worlds, making the moon both an end in itself and a stepping stone to infinity. The moon reminds us of duality, bright yet dark, near yet far, barren yet full of meaning. It embodies opposites. It is both a rock in space and a symbol of love, both an object of science and of dreams. Its very nature invites us to hold wonder and reason together. The moon is Earth's partner in destiny. From shaping tides to stabilizing climate, from inspiring myths to hosting explorers, it has been with us since the beginning. Wherever humanity goes in the cosmos, the moon will remain the first other world we called home. The moon's surface is covered in a fine, powdery dust called regolith, created by billions of years of meteoroid impacts, grinding rock into particles so small they cling to everything like static. Apollo astronauts found it so clingy it stuck inside their suits, smelled like gunpowder, and irritated their lungs. Unlike Earth, the moon has no atmosphere thick enough to shield it, so meteorites slam into its surface constantly, leaving craters large and small. Some are as big as countries, like the South Pole Lightkin Basin, which spans more than 2,500 kilometers and may be the largest known impact. Crater in the solar system, the moon's far side, often called the dark side, isn't actually dark. It receives as much sunlight as the near side, but remained hidden from Earth until the space age. When the Soviet Luna 3 probe sent back the first photos in 1959, humanity saw its mysterious, heavily cratered face for the first time. The moon causes Earth's tides by tugging on our oceans with its gravity. Without it, tides would be weaker and less predictable, changing how marine life evolved. Some scientists even believe early life may have relied on tidal pools stirred by the moon's pull to make the leap from chemistry to biology. Though it seems bright in our night sky, the moon's surface is actually darker than asphalt. Its high reflectivity is more an illusion of contrast against the black of space than true brightness, which is why astronauts describe the surface as surprisingly dull gray up close. The moon slowly drifts away from Earth at about 3.8 centimeters per year, roughly the pace fingernails grow. In the deep future, this widening orbit will lengthen our days and weaken tides. Millions of years from now, total solar eclipses will no longer happen because the moon will appear too small to cover the sun completely. During the Apollo missions, seismometers were left behind that detected moonquakes. Unlike earthquakes, these tremors could last for hours, caused by tidal stresses from Earth's gravity and temperature changes from lunar day to night. The ringing quality made scientists compare the moon to a bell when struck. Because the moon lacks an atmosphere, there is no wind or rain to erode features. This means footprints from Apollo astronauts and tracks left by rovers may last for millions of years. Unless disturbed by micrometeorite impacts, the moon preserves its history in a way Earth cannot. While the moon is lifeless today, scientists speculate that billions of years ago, it might have briefly supported a thin atmosphere and possibly liquid water on its surface. Volcanic eruptions released gases that created this short-lived environment before it dissipated into space. The moon is tidally locked to Earth, meaning the same side always faces us. This is not coincidence but the result of billions of years of gravitational interactions. As it rotated, Earth's pull gradually slowed its spin until it matched its orbit, locking it into its familiar orientation. Ancient cultures across the world used the moon to track time, months, derived from moons, were originally based on lunar cycles of about 29.5 days. Many calendars, such as the Islamic calendar, still follow lunar months instead of solar ones. Despite being airless, the moon does have a very thin exosphere made of helium, sodium, and other trace gases. This ghost atmosphere is so delicate that a single human breath contains more molecules than a cubic meter of lunar exosphere. The moon's poles hold permanent shadows in deep craters where sunlight never reaches. These cosmic freezers preserve water ice, believed to have been delivered by comets. This ice could one day be mined by astronauts for drinking water, oxygen, and rocket fuel. Some ancient astronomers believed the moon was perfectly smooth, a flawless heavenly body. It wasn't until Galileo in 1609 pointed his telescope and saw mountains, craters, and valleys that humanity learned the moon was scarred and rugged like Earth. Eclipses are possible only because the sun is about 400 times larger than the moon, but also 400 times farther away, making them appear nearly the same size from Earth. This perfect alignment is a cosmic coincidence that won't last forever. The moon has inspired countless myths. In China, the story of change tells of a woman who flew to the moon, where she still resides with a jade rabbit. In Native American traditions, the moon often appears as a guide or guardian watching over the Earth at night. Some early scientists thought the moon might be covered with vegetation, oceans, or even civilizations. These ideas persisted until the space age. Even in the 1830s, a hoax newspaper story described fantastical creatures on the moon, sparking widespread excitement before being debunked. The moon's maria, the dark plains visible from Earth, are ancient lava flows. They were created billions of years ago when massive impacts fractured the crust, allowing molten rock to flood the surface. Their smoother appearance contrasts with the rugged highlands. While the moon is Earth's only natural satellite, scientists have discovered tiny quasimoons that orbit the sun, but stay near Earth. These are not permanent companions like the moon, but share space in our gravitational neighborhood. The moon rotates once on its axis in the same time it takes to orbit Earth, about 27.3 days. However, because Earth also moves around the sun, the full lunar cycle from one full moon to the next is 29.5 days. This difference is why months are slightly longer than the moon's orbital period. During a total lunar eclipse, Earth blocks sunlight, and the moon glows red instead of disappearing. This happens because Earth's atmosphere bends light, filtering out blue wavelengths and allowing red light to reach the lunar surface, giving it the blood moon effect. The moon is thought to have formed about 4.5 billion years ago when a Mars-sized body called V collided with Earth. Debris from the impact gathered in orbit and eventually coalesced into the moon, making it a direct sibling of our planet. The moon affects Earth's axial tilt stability. Without it, our planet might wobble chaotically, leading to extreme shifts in climate. Scientists believe the moon's steadying presence helped create conditions for life to thrive on Earth over billions of years. Astronauts who visited the moon left behind more than just footprints. Flags, tools, rovers, and even bags of waste remain on the lunar surface. These artifacts serve as a time capsule of human exploration. The moon's horizon appears much closer than on Earth due to its smaller size. Apollo astronauts often misjudged distances, thinking nearby hills or craters were within walking distance when they were miles away. Because the moon has no weather, its sky is always black, even during the day. Standing on its surface, one could see stars even with the sun shining, something impossible on Earth due to our bright blue atmosphere. The moon's gravity is only 1/6 that of Earth, meaning a person who weighs 180 pounds on Earth would weigh just 30 pounds there. This reduced gravity allowed astronauts to take bounding, floating steps and made carrying heavy equipment easier. The moon influences human culture deeply, from harvest festivals timed by its phases to literature, art, and music inspired by its presence. Poets from Shakespeare to modern writers have used the moon as a symbol of love, mystery, and change. The far side of the moon has far more craters than the near side. Scientists think this is because the near side's crust is thinner, allowing lava to resurface craters and smooth them out, while the far side's thicker crust preserved its ruggedness. NASA's Artemis program aims to return humans to the moon, this time to stay. Plans include building a lunar base and using its resources to prepare for deeper space missions. including journeys to Mars. Unlike Earth, the Moon does not have a molten core that generates a magnetic field today. However, ancient lunar rocks show signs that it once had a magnetic field billions of years ago, possibly from a molten interior that has since cooled. The Moon's temperature swings are extreme. Without an atmosphere to regulate heat, daytime temperatures can soar to 127 degrees Celsius (260 degrees Fahrenheit), while nighttime plunges to -173 degrees Celsius (-280 degrees Fahrenheit), making survival on its surface a major challenge. Lunar soil contains helium, a rare isotope that could be used in nuclear fusion. Some scientists dream of mining the Moon for this resource, which could provide clean energy if fusion technology becomes practical. The Moon's orbit is elliptical, so its distance from Earth varies. At perigee, the closest point, it appears larger and brighter in the sky, creating the supermoon phenomenon. At apogee, it appears smaller, sometimes called a micromoon. The Moon is the fifth largest moon in the solar system, smaller than Ganymede, Titan, Callisto, and Io, but far larger relative to its planet than any of them. This unusually large size compared to Earth is what makes it so influential. In many cultures, the Moon is associated with femininity, cycles, and fertility, reflecting its monthly phases. Myths often paired it with the Sun as male and female counterparts, symbolizing balance and duality. Future lunar explorers may face unexpected challenges from dust. Lunar regolith is sharp and abrasive, capable of damaging equipment and spacesuit seals. Designing technology to withstand its effects is a critical part of space engineering. The Moon is gradually slowing Earth's rotation. In the distant past, days were only about 18 hours long. As the Moon continues pulling tides, Earth's rotation slows, and days lengthen, a process that will continue for billions of years. Some of the Moon's craters, like Tycho, are visible to the naked eye and radiate bright rays of ejected material that stretch thousands of kilometers. These ray systems formed from relatively recent impacts and remain striking features. The Moon has no plate tectonics, so mountains form differently. Many lunar mountains are uplifted edges of impact basins, rather than tectonic collisions, making their origins alien compared to Earth's ranges. Though lifeless, the Moon has become humanity's first stepping stone into space. Every mission there reflects both our technological limits and our unending curiosity, making it not just a celestial body, but a mirror of our aspirations. The Moon's synchronous rotation means we see only one face, but from Earth we can glimpse about 59% of its surface over time. This is because of a phenomenon called libration, where the Moon wobbles slightly in its orbit, revealing hidden edges. Before telescopes, people imagined the man in the Moon, or other figures etched into the lunar face. Different cultures saw rabbits, toads, or even lovers, showing how human imagination projected stories onto the same gray patterns of Maria and Highlands. The Apollo missions left retroreflectors on the Moon, small mirrors still used today to measure the exact distance between Earth and the Moon. By bouncing lasers off them, scientists confirmed the Moon is slowly receding at centimeters per year. Ancient sailors navigated by both the stars and the Moon. Lunar phases helped track time at sea, while eclipses allowed explorers to estimate longitude long before precise clocks made the process easier. The Moon plays a role in animal behavior. Many marine species, from corals to fish, synchronize spawning with lunar cycles. Even predators like lions hunt more successfully during darker moonless nights, because the Moon's gravity affects Earth's crust as well as its oceans. Some scientists studied whether earthquakes might correlate with lunar phases. While not strongly proven, tidal stresses may contribute to subtle geological effects. The Moon's far side contains a striking difference in crust thickness compared to the near side. This asymmetry puzzled scientists and may hold clues to how the Moon cooled and evolved after its fiery birth. Even in modern times, the Moon inspires mystery. In 1969, during Apollo 10, astronauts reported hearing outer space music, strange radio signals that turned out to be interference. But the story fueled conspiracy theories for decades. The Moon's gravity is weak, so it cannot hold onto significant amounts of water vapor. But frozen water in shadowed craters provides a treasure trove for future explorers, possibly supporting entire lunar colonies. The Moon has no atmosphere to scatter light, so shadows there are stark and pitch Astronauts described the eerie difficulty of judging depth in such harsh lighting, with bright sunlit surfaces right next to absolute darkness. In myths, eclipses were often seen as ominous. Ancient Mesopotamians believed lunar eclipses foretold the death of a king, so they sometimes installed temporary substitute kings during eclipses to protect rulers from fate. When viewed from space, Earth shines 100 times brighter in the lunar sky than the moon appears to us. Astronauts described Earthrise, the sight of our blue planet rising over the lunar horizon, as one of the most breathtaking visions of all time. The moon has regions permanently bathed in sunlight near the poles, called peaks of eternal light. These rare mountain tops could provide continuous solar power for future lunar bases. Lunar dust is not only abrasive, but also electrostatically charged by solar radiation. This charge makes particles levitate slightly above the surface, forming a thin, shifting haze visible at the horizon during sunrise and sunset. Throughout history, lunar calendars guided planting, harvesting, and rituals. Farmers watched for full moons like the harvest moon or hunter's moon to time work and celebrations. These names still persist in modern ALMANACS. Apollo astronauts left behind personal items, family photos, medallions, and even a small sculpture called the Fallen Astronaut, honoring explorers who died in space exploration. These artifacts transformed the moon into a human memorial. The moon's gravity field is uneven due to dense masses beneath the surface, called mascons. These anomalies tugged at early spacecraft, causing navigation challenges until scientists mapped them precisely. Volcanic domes on the moon hint at past eruptions of sticky lava. While most lunar volcanism ended billions of years ago, evidence suggests some small-scale activity may have occurred as recently as 100 million years ago. The moon is not perfectly round but slightly egg-shaped, with the larger end pointing toward Earth. This elongation was frozen into its shape during its early molten state under Earth's gravitational influence. In astrology, the moon symbolizes emotion, intuition, and cycles. While not scientific, this cultural role shows how deeply humanity tied its inner lives to the rhythms of the moon. The moon has served as a practice ground for space technology. Concepts for habitats, rovers, and power systems tested for lunar survival may one day support colonies on Mars or even farther worlds. Some legends imagined the moon as a mirror reflecting human life. Folklore said marks on its face changed depending on human behavior, turning it into a cosmic overseer of morality. Because the moon has no sound-carrying air, the surface is utterly silent. Astronauts could hear only their own breathing, heartbeats, and voices in headsets, creating a hauntingly lonely environment. Every full moon rises at sunset and sets at sunrise, opposite the sun in the sky. This predictable relationship has made the moon a tool for keeping track of time for thousands of years. NASA's planned Lunar Gateway, a small space station orbiting the moon, will serve as a hub for exploration. It represents humanity's first attempt at building permanent infrastructure. In cislunar space, the moon's regolith contains tiny glass beads formed by volcanic eruptions and meteoroid impacts. These beads preserve chemical information about the moon's ancient interior and volcanic history. Lunar eclipses always occur during a full moon, while solar eclipses always occur during a new moon. These alignments are predictable centuries in advance, and ancient astronomers used them to test their understanding of celestial cycles. The moon inspired countless works of art. Vincent van Gogh painted Starry Night with a luminous crescent, while Japanese woodblock prints often placed a full moon above landscapes, celebrating its beauty. Apollo astronauts noted that without wind, dust kicked up during walks settled instantly in arcs, not drifting as it would on Earth. The lack of atmosphere created an alien sharpness to even the smallest motions. While no life exists on the moon, some organisms from Earth have visited. Tardigrades, tiny, resilient water bears, may have survived a crash landing of a private spacecraft in 2019, potentially lying dormant on the lunar surface. The moon subtly affects human sleep. Studies suggest people may sleep less deeply and for shorter durations during full moons, though the cause remains debated, perhaps tied to brightness or ancient circadian rhythms. In 1971, Apollo 15 astronauts drove the first lunar rover, traveling over 27 kilometers. The rover extended their range and proved wheeled vehicles could function in the low-gravity, dusty lunar environment. Unlike Earth, the Moon does not experience colorful sunrises or sunsets. With no atmosphere to scatter light, the Sun simply rises as a glaring orb over a black sky, transforming shadows instantly. The Moon has been a canvas for imagination in science fiction. From Jules Verne's From the Earth to the Moon to modern films, it has remained a stepping stone between Earth and the stars in our collective dreams. The Moon's gravitational influence stabilizes Earth's wobble, but it also creates a precession cycle, a slow, 26,000-year drift of Earth's axis that subtly changes which stars mark the North Pole. Without the Moon, this cycle would be far more chaotic. Astronomers have mapped the Moon more thoroughly than Earth's ocean floors. Modern missions like the Lunar Reconnaissance Orbiter produced high-resolution maps that helped plan future landings. Some cultures once believed eclipses were caused by monsters devouring the Moon. In India, the demon Rahu was said to swallow it, only for it to reappear when the demon was beheaded and the Moon escaped. Despite centuries of study, mysteries remain. Why is the Moon's far side so different? How much water ice exists in polar craters? Each new mission reveals more questions, ensuring the Moon continues to intrigue. The Moon may one day serve as a launch pad for deeper space exploration. With its weaker gravity, rockets launched from lunar bases would require far less fuel to reach planets beyond.